This conference is brought to you by CallStack, a total software engineering consultancy.
Thanks for the intro, Mo. I was actually thinking maybe I should have actually come out on a unicycle. Would have really been like continuing that. All right. I'm very aware that lunch is up next, so I will try to be as quick as possible. So my talk is hard-learned lessons in app scaling. So what can we learn from building an app that scales to hundreds of engineers and millions of users? This talk is for people who are either currently building or planning to build an app that needs to scale, like this or beyond. And if that doesn't describe you, don't worry, maybe you just want to hear how things can actually fail and go wrong in like spectacular ways. There will be something for everyone. So hello, I'm Mike Duminy. I'm a principal engineer and architect at Klarna. I've been working with React Native since 2016. And today I want to share some lessons that we've learned while scaling our Klarna app to over 350 engineers working on it for 6 years. We've got 30 million monthly active users and something like 85 million app downloads. All of this results in each screen being rendered like 1 billion times a month. So for context, let me tell you a little bit about the company. Klarna is a global shopping and payments company from Sweden. Probably best known for our buy now, pay later product and hopefully our shopping app. Now the app allows you to do a whole host of shopping related activities, so I recommend you check it out if that's your gig. You can do things like all of those, find great deals, track prices over time, place orders, track deliveries, etc. Now the app is built almost entirely in React Native. And it shares, I'd say, most of its code base, like 90% of its code base with our web app and our browser extension. So everything's built from the same code base. So we almost have like a framework internally that our developers work against. And it's comprised of about 4,000 different packages or yarn workspaces spread across 2,000 screens or routes, probably north of 200 features today. And every day we merge at least 40 times. So in this talk, I'm going to tell you 4 short stories of failure or struggle that span roughly the last 4 years and give you some lessons that we've learned from it and maybe they can help you. So just to sort of preface all of this, I work on the platform team. And so for this talk, I want you to imagine that you're on this team with me, because that's the lens that we're going to be seeing all these stories through. On top of the platform, feature teams build user-facing features, and then of course users use the app. Now, as a platform team, your customer is not just feature teams, but it's also users, so you need to think about the whole ladder. So our first story. This starts about 4 years ago, and at that time, the app had launched in several different countries, and Klarna was growing rapidly. We started getting hundreds of reports on Google Play and social media that our Android app was just like terribly slow. And so clearly some people even thought we were just wrapping a web app, and we definitely weren't. So how did this happen? Well, most of us were actually developing on iPhones primarily, so Android got less attention. And we knew the performance of the app on Android wasn't great, but we didn't expect it to be this bad. It took about 30 seconds to start the app. Now, don't worry, that's not on the flagship devices. This is on low-end, but popular devices. So that is clearly ridiculous, and immediately the company just invested a lot of time and resources into solving the problem. So we started this process as all good performance investigations start by measuring. We took the boot sequence apart, and we added performance markers to get timing for each section. Now, this is not a talk about performance, but I mean, there's loads of those out there. But I can't tell the story without mentioning at least 1 or 2 things that we did. So here they are. If we focus just on this stage, which is actually as the JavaScript bundle is getting evaluated, we found very clear low-hanging fruit that we could just change, such as taking steps that were done in sequence and make them parallel. Of course, this reduces the waterfall effect. Secondly, we noticed some really slow code paths in our investigations. One of them was when we were trying to call React Native keychain, and there was like a really slow code path that we hit on app boot as we were trying to access like the secure element on the device, and this particularly affected older Android devices. So we upstreamed fixes, and just solving this netted us like 10 seconds. Then we decided, well, how do we shorten that pink bar? Well, you just load less code. So we took the step of switching our production bundler from Metro to Repack. If you don't know what Repack is, it's a bundler built by CallStack, so shout out to them. That was really, really cool. Repack essentially like builds on top of existing good practices on the web. So today it basically wraps Webpack under the hood, and it let us use code splitting and tree shaking just to load less code. So in the end, this fast forwards quite a bit, but in the end we got it down from 30 seconds to under 3 seconds on that same device, which was an awesome 10x improvement. It was bad to begin with, so like it was back to normal, let's say. And then as a happy byproduct of this, because we were touching the boot of the app, iOS also got significantly faster. All right, so what? What does this have to do with scale? Well, take a step back and ask yourself this question. How did we ever reach this point? How does a company with hundreds of engineers working on the product somehow miss this glaring problem? If you asked us if startup time was important, we would say, yeah, of course it is. But the problem is we weren't tracking it. And if you don't track something, how do you actually know how well you're really doing? Or actually, how do you know where things go wrong or go right over time? So that brings us to our first takeaway. That is that we should measure what matters. So when you're building at scale, it's important to keep your eye on some of these key metrics. Of course, what matters to you is kind of nebulous. It depends on your project. That's why my first step is to figure out what matters. And for this, you can consider things that you might normally take for granted, such as the bundle size, maybe the number of dependencies, or in our case, time to interactive. Secondly, you would want to actually automate these measurements. So it's not just someone sitting on their device running the tests, but something that you can just send to CI and get a report back. Then you want to track that over time so you can see how you're doing. And finally, and this is probably the most important one and was a big learning for me going into the company, was you need to connect this kind of stuff to business goals. So whatever is most important, make it important to the business too. So it might be most important to you, but maybe the business is not fully aware of how important it is. So what we did is we elevated our metric to a key performance indicator, or KPI, which is then routinely reviewed on like a group level for us. So our success is tied to this metric. Okay, so we'd solved this glaring problem and we'd improved start times for everyone. More importantly, people could use the app, and it was good for a little while. That brings us to story number 2. If you fast forward a few months, another issue pops up. All of a sudden, we get reports of a super slow and unresponsive app. All right, now what? So when you opened the app, it kind of looked something like this. As soon as you logged in, everything kind of ground to a halt. The homepage wasn't really loading. There were just skeleton loaders everywhere. Maybe some content would pop in. But yeah, the app was kind of broken. This time, it wasn't just on Android, but it was also on iOS. And all the live versions were affected around the same time. If you had to guess what the problem was, maybe you'd think this is in our service layer, right? Maybe our services have just gone haywire and they're not responding with content. But they were fine. So what gives? we had to dive a little deeper. And when we profiled the app, we saw that on login there were a ton of requests all getting sent out to the same host. It was a website that we had built. So what is this about? Let me explain. In order to optimize the customer experience, one of the features was hooking into the on-boot of the app. During on-boot, they would download this entire website to local files. And the idea behind it, I guess, was sort of good. Like they wanted to show this in a web view later, and they wanted the load up times for that to be like super quick. So it almost looked like it was just normal native code. But, of course, it went wrong. So what was 5 requests turned out to be about 800 when this problem happened. And what ended up occurring was that like the chunking strategy had changed on the website. So someone had touched the Webpack config and inadvertently triggered a way more aggressive chunking strategy. So what this meant on the app was that it would kick off 800 requests as it started at the time when it's loading all the other data in the app, and essentially completely starve the request pool and break everything. So let's zoom out again. How did this happen? As we suspected, this wasn't something inside of the app, it was external, but it wasn't our service layer, it was like some other connection. But remember, we're thinking as a platform team. So what, as a platform team, do you have control over? Well, if we think about this, the only way this team was able to do it was to hook into the on-boot callback of the app, which was a feature that we had offered to them. So this is a pretty convenient thing to have in an app, I guess. As a feature team, I would appreciate it because it could allow you to do some hopefully light preloading of your feature or setting up some listeners to other parts of the app or events that are getting emitted. Yeah, it seemed like a good idea. But what was a good idea at a smaller scale, when we got bigger, it became pretty risky. So it turns out whatever you offer will be used and misused, however well-intentioned those usages are. To be fair, in the example, the team was simply trying to optimize for their use case and their users. They were, in their minds, doing a good thing using available APIs. Of course, it was having a bad effect, but the intention was good. This brings us to takeaway number 2. It's quite a simple one, just restrict your APIs. That means building them defensively. So think about when you're building them, how could they be misused? How could they be used to break things? The next point here would be to actually limit access to any risky APIs that you do still offer. And you can do this by using code ownership rules or static type checking, static lint checking maybe, or even just snapshot testing to see like who are the users of this. Or you can do the well-known approach, which is just to prefix the function name with something like internal do not use or you will be fired. Moving swiftly on to story number 3. Now, given the problems that I've just described with startup and misuse APIs and a whole host of others that I couldn't get to, we wanted to evolve our architecture to become more resilient. Now, changing architectures is one example of a very common practice that we're probably all familiar with, that of migrations. In smaller code bases, migrating from A to B, maybe you're swapping out even something significant like a navigation library, you're talking probably about days or weeks maybe to get that done. This is not the timeline in a really large app. And yet migrations are a fact of life, so how do you do this? To describe what we were trying to do, we were basically taking our app, which was sort of monolithic, and we wanted to move over to Yarn workspaces or packages, so break up each feature into its component pieces. This actually gave us a lot of different benefits, like once we had this graph, we could, for instance, only run the tests on the packages that were affected by the changed code. So it has outsized good effects on our DX and CI, so among other things. But in order to do this, teams would need to think carefully about how do they take their single feature and break it apart into these pieces that each have their own dependencies and dependents and rules about like who can import who. So just as a quick check, thinking as a platform team, how long would you estimate this takes? Well, let's give you some facts. Our app is about 2 million lines of code across 200 features. And like I mentioned, all the other stats, 2,000 screens, etc. If you're thinking anywhere in the region of 6 months, I would say you're quite optimistic. Bear in mind that while you're doing this, there's a whole host of other stuff that's going on. Like, you're not the only people who want to get something done in the app. There are product launches, critical bugs to fix, just like planned marketing moments. You can't stop everything and migrate. In the end, it took us 2.5 years to get this done. And I want to just draw attention to the last 10% on this graph. That took us about a third of the time. And this is very typical, as far as we can tell, for migrations at scale. There's always a really long tail. So to solve this, we just redoubled our efforts and put in the grunt work to help the teams get over the line or just do it ourselves. Now, one other thing to consider about this architecture is that originally we wanted it to be a completely clean break from the old one. We actually designed it that way. We didn't allow any interoperability, and teams were not encouraged to do that. But we very quickly realized this wasn't actually feasible, because any feature, I mean, you could have really small features, but you could have really big ones as well. And it's not practical to ask teams to migrate their entire feature over to this packages world when they could actually rather just migrate bits and pieces as they touch it. This is also less risky to do it this way, because you would assume that the code is battle tested and it works as it is, so you don't want to touch anything unnecessarily. So we decided to relax some of our initial rules to allow interoperability between these. So for instance, the old architecture could import from the new architecture, but not vice versa. And this enabled teams to migrate incrementally. That is our third takeaway. So when you plan for migrations at scale, prepare, when you're thinking about it, to actually migrate incrementally, and what does that mean? So my tips for you, and there are a whole host of these on the internet as well, but the ones that stood out to me were to actually enforce the rules of the new architecture. So let's say like that import example that I gave, that should be enforced at a CI level. But crucially, only for new code, only for code that's already in the new architecture. Said another way, existing code needs to be able to violate your rules to some degree. So sometimes you need to relax the rules in order to move forward. Secondly, once everything's set up, you want to motivate teams to migrate. You don't want to just be like a dictator and say, everyone do it right now, or insert yourself into their backlogs. You also want to add some carrots to it, and rather not using sticks. So what does this mean? It means like communicating the value of what does the migration actually give to that team. In our case, it gave us the ability to develop in isolation, or to only run tests on certain parts of that graph that I showed. And that is a benefit for everyone, but also the team migrating. And finally, and once again, like the other one about connecting it to business goals, you need to communicate to product managers what the value is, convince them that this is a good idea, and this will help the migration to actually move forward, both from a technical pressure perspective, but also from product. You have a far higher success rate if you do that third one. And this brings us to our fourth and final story. I wonder how many people have seen this. So all of a sudden, our developers, once again, 300 plus, all started getting this error locally. Just when they're just trying to start the app in dev mode. So To me, this looks like recursion off the bat. Probably some commit introduced recursion inadvertently or as a bad actor, who knows. So, of course, the easy fix is revert the commit that caused this, right? That's the simple way of doing it. Well, we used git bisect. We found the offending commit and noticed nothing out of the ordinary. And when we reverted it, the problem didn't go away. All right, pretty confusing. Now, of course, this is blocking development, and blocks teams can be able to respond to like crucial bug fixes or incidents and things. So we're going to have to take a closer look. Let's check out the facts. So it only happened in dev. We confirmed this pretty early on. It never touched our production app. That might have been because we were using repack and used code splitting, but this was at least a saving grace. Also, there was no obvious cause, right? The git bisect didn't reveal anything. Looking at the commit didn't reveal anything. None of our static analysis tools checking for require cycles, none of that revealed anything new. And crucially, there was no stack. So it was like a blind error. Like, how do you figure this out? So we did the classic approach of comment-driven development. This is an awesome way of just debugging very quickly what the issue could be or where it could be. So in this example, we have like a central function that creates all of the routes. It composes the routes from all the features. And we found that if you just comment out one of the features, it works. Sweet. We've unblocked development for the app. It's cumbersome, and I mean, it's horrible for that feature, but you know, at least all the other features can still work. So we can tell people to do this to unblock themselves. We actually ended up building a tool that allowed you to specify which routes you want to run, and then you can just run a slice of the app. So that's like a positive outcome here. But what was it about this commented out feature? It was nothing. It turns out it doesn't matter what you commented out, as long as you commented out enough. All right, what does that mean? Now, this is pretty confusing, but it implied that we had reached some sort of hidden limit that we were just completely unaware of. It also wasn't a long-term solution because, I mean, you can't just continuously do this. It's like fixing race conditions with set timeout. So we settled on the idea that perhaps we just have too much code, which could be true. And maybe that code is too interconnected. Also, probably true. But without knowing where that limit lies or what exactly was causing it, we were kind of lost, because even if we had fixed both of these, we had deleted code, we had disconnected it, we still have no guarantee of when we would hit this limit again. So it was too vague for us. So we had a hunch that it was something to do with Hermes. And the reason we thought this is because we were tracking down that error message, and we found mentions of something similar, but not the exact same, in other issues in Hermes. It mostly had to do with like importing large JSON files, which once again was not what the commit that broke it was doing. So yeah, we followed this up, and we thought, you know, this doesn't match it exactly. No one's experiencing our problem like as we see it, but this could at least point us in a direction. But we can't just give the Hermes team access to our code base. That's crazy. So we had to reproduce the crash. We created a repo that could simulate a large app. So given a specific number, it would generate that number of files and then connect them all together and include them in a bundle. We reproduced the crash at around 50,000 files. And then we shared that broken bundle with the Hermes team. And I'm glad to say they found the problem very quickly. Thank you to Neil, who is here, actually. He said this: the size of the global function is causing the register allocator to hit a memory limit and fall back to fast but very inefficient allocation. All right, if you don't understand that, don't worry, I did not either. But reading between the lines, it sounds like there are some limits in Hermes, and we had hit that with our specific use case, or at least with that number of modules. So we further found out that the only reason we were experiencing this in dev was because it only affected on-device compilation of JavaScript. So you'd have to have a really big app, like, I don't know, maybe like 100 meg plus bundle, and you would need to be shipping this to devices, which I guess you could be doing if you're not using Hermes, but it's like becomes less and less likely as most people are using Hermes to pre-compile. And the pre-compilation step was fine. Now, also happy to say that this is actually fixed in React Native 75. So shout out to the Hermes team. Thank you so much for getting this in. And I'm hoping we can get it backported further. But yeah, TBD, we'll see. So what can we learn from this story? Well, for me, it is that, you know, at scale, you're going to run into problems where there's no Stack Overflow answer that is readily available. There's no code you can just copy paste. AI is not helping you. Nothing is like really giving you many hints. At these times, my advice is to embrace the challenge. You're going to learn a lot, and you're going to become a better problem solver. So some very quick tips on how to do that. Well, be willing to dive deep, I think is the first thing. It's like more of an attitude. And what does that mean? That means diving deep into the open source code that is available for the tooling that we use, the issues thereof. Maybe diving deep into how exactly does bundling work in Metro, in Webpack, what does the output look like, how could that possibly be affecting whatever the problem is that you're experiencing. And secondly, is to connect with the open source community. There are a lot of great people there who are more than willing to help out, provided, of course, that you do enough work to help them help you. And that's it. In summary, we've explored 4 key lessons that we've learned at Klarna. You know, that where scaling an app is like full of fun challenges and learning opportunities. And they are to measure what matters. That means identifying and automating the measurement of critical metrics so that there's no surprises later on. 2 is to restrict your APIs. So build your APIs defensively and limit the access to risky ones. 3, when approaching migrations, think about them as incremental. Like if they could take 2 years, how would you do it if you knew that up front? So yeah, and also plan for both systems to coexist at the same time. And finally, the last one is just to embrace the challenge. You know, unforeseen issues will arise. You're going to hit weird limits, weird things that happen. But these challenges are, although they could be frustrating, I would rather say that you should frame them as opportunities to deepen your understanding of the tooling that you're using and improve your problem-solving skills. And as we've shown, these lessons aren't just theoretical. You know, they come from real-life stories, and they've helped us to scale our React Native app at Klarna. And I hope these have been helpful to you. If you have any other tips, please share them publicly as well. That would be great, because we also always want to learn. And feel free to connect with me. It's my handle there is in the bottom right, without the Klarna bit. And yeah, grab me for any questions after this if you have. Thank you.
Thank you very much, Mike.